Hello everyone, I am Dr. Ajay Kumar MB. I am the Deputy Director Research for International Union Against Tuberculosis and Lung Disease. In this presentation, I am going to explain what a data documentation sheet is all about. The key objectives of this presentation is, first I'll provide a brief overview of EpiData Entry, what we are going to learn in the next 2 days. We will understand the utility and how to prepare a data documentation sheet. We will define and understand the important terms in EpiData, like what's a field value, what's a value label, what do you mean by a record, what's a file, etc. etc. We will also define the different types of fields or variables and know how to use them. Now, these are the objectives of this particular presentation. Let me kick off by giving you an overview of what we are going to do in the next couple of days. As you clearly understand by now, the task is to create an electronic database. So we have collected data, they are in paper-based forms. So that is where we are going. So we begin with our original data source. This could be a register, it could be a treatment card, it could be a questionnaire which you have filled after interviewing people, or it could be any data collection pro forma. So this is the source of data. Now from here, we want to enter it electronically and make an electronic copy. Now to achieve that particular task, we have to go through certain steps. Now, EpiData helps us in creating that database, which can create an electronic copy of your paper-based data collection pro forma. But before you use EpiData to create the database, the first step in this process is to prepare a data documentation sheet or a codebook. Now, this is nothing but a plan for data entry, a clear developmented roadmap for developing database in EpiData. Now this is like creating a plan, developing a plan before you construct a house. And in fact, the plan should be so detailed that if you give this plan to somebody who knows how to construct the house, he should be able to do it on his own. Now similarly, before you construct an EpiData database, you need to lay out a plan. And that's exactly what data documentation sheet is all about. It's also referred to as codebook in EpiData language. Now, once that is done, then the next steps are straightforward. You have to make a quest file, a rec file, and a check file. Now, before I go there, I have to clarify that please do not confuse data documentation sheet with a data collection pro forma. Now, data collection pro forma is what is a sort of a paper-based form that you use to extract data from the original data source, or what you document when you are interviewing patients. Now, that data you want to enter it electronically, but data documentation sheet is nothing but a code book. Okay, I hope there is no confusion between the two. Now, once you have the data documentation sheet, you use that to make the classic EpiData triplet files. Now, there are 3 kinds of files that form the core of the EpiData database. And these files are called quest file, rec file, and check file. Now, the first step is to make a quest file. What's a quest file? Quest file is a questionnaire file which defines the structure of the database and provides a framework or a layout for data entry. Now this is the one which defines exactly what is the name of the variable, how many variables are there, what are the labels of these variables, and what are the types of variables. Now all of this is defined in a quest file. Now once the quest file is ready, then you make a rec file. Rec file is also called as a record file, which actually is the home of all data. So this is the file into which we will do data entry and houses all our data. Once we have, in fact, the quest and rec, these two are enough to begin data entry. But what makes EpiData smart is actually the check file, because check file holds all the data checking rules that it has to look for during data entry. So for example, if you want, let's say there is a variable called age, and you want to restrict the values that are entered into field between 15 and 90. Then you can define a rule that these are the only range of legal values this field can take. Similarly, if you want, let's say there is a variable called sex, and there are only 3 or 4 options: male, female, transgender, and maybe missing. So if you want the data field to allow only these 4 options and nothing else, so that is a rule that you can define. And all of those rules are defined in a check file. And that is what makes EpiData smart and quality assured. Is this clear? There are 3 files: the quest file, which defines the structure of the database, the rec file, which houses all your data, and the check file, which defines the rules of data entry. These 3 triplet files, sort of belonging to a same family, are the core of the EpiData database. Now, once this is ready, you are ready to begin data entry. And as we explained earlier, we want to do double data entry and validation. So then we will learn, how to set up for double data entry. And once it is set up, and we'll give you an example data where you can actually do double entry and then validate or compare the 2 databases and look for discrepancies and list all the discrepancies, go to the original data source, make a final data file which has all the corrections, and use that. Once that is done, it's a clean data set which either you analyze in EpiData or export it to other softwares or other formats like Stata or SAS or SPSS in which you want to analyze. Now, this is in brief what we are going to learn in EpiData Entry. Let's kick off. So let's know more about data documentation sheet or a code book. This is an example of a data documentation sheet that you are seeing here. And there are several terminologies that we have to learn here. And if you look at this, field name, there is something called field label, field type, field length, field values, value labels, and then there are some comments. So this is a document which clearly tells what are the variables that you have and the several attributes about each variable. Now let's go through these terms one by one. Let's look at field name and field label. What's a field name? In EpiData, variables are referred to as fields. So a field name is nothing but the name of the variable. And there are certain rules in the way we define a field name, and we'll come to those details in a short while. But field label is nothing but the full name of the variable or the detailed explanation of what this field is all about. And here EpiData has less restrictions. In fact, you can provide a full sentence as to what this particular field refers to under field label. Let's look at field name. What are the rules? The first rule is that the field name has to be unique. Each variable should have a unique field name. You can't have the same name for 2 variables in a database. This is a no-no. So please note, this is the first rule in defining a field name. The second rule is that it has to be a single word, which means that there are no spaces, no punctuations, no underscore, nothing. It's just a plain single word, and it should not be more than 10 letters. In fact, I would encourage you to keep it to 8 letters, because some of the other softwares that I know of can only permit 8 characters for a field name. So if you are going to use EpiData for data entry and export the data to analyze in other softwares, you may get into trouble. So I would say, even though EpiData allows for 10 characters, 10 letters, restrict yourself to 8. And the other important thing is the field name should be intuitive. The moment you look at the field name, you should know what exactly it means. For example, a good age. Age is a good field name, and it clearly tells you that it refers to the age of the person. Or sex is another good field name. It's short, single word, and tells you exactly what it means. Don't use field names like V1, V2 or Q1, Q2. These are not intuitive and requires you to remember these things all the time. Some of the other tips in assigning field names. We've discussed about choosing names intuitively already. The other important thing is, please make sure that the name of the variable and the first word of the variable label are not same. This is a small glitch that is there if they are same. So for example, if the name of the variable is sex and the name of the variable label or the field label is sex of examinee, then what happens is when you analyze data, the first word gets truncated in the label. So instead of sex of examinee, it gets truncated as of examinee. So the first level is chopped off. Although this can easily be fixed in EpiData analysis is not really a big problem, but you can prevent it by choosing a label which doesn't begin exactly with the same word as the name of the variable. So instead of sex of examinee, you can say examinee sex, and then that problem will not be there. The other important rule I would like to follow in assigning field names is to use lowercase. In fact, if you remember, in our previous session, I showed you exactly how to force EpiData to ensure that all the variable names are going to be in lowercase. While EpiData itself is not case sensitive. So for example, sex as in lowercase or in uppercase or in sentence case, they all treated similarly in EpiData. Other softwares don't treat it similarly. So if you're using EpiData for entry and exporting the data to other softwares for analysis, you have to be careful about this. And in setting options, we have already forced this. Under the create data file tab, we have said use lowercase for field names. So that is taken care of. The other couple of tips is that do not use words like date, month, and year. These are functions in EpiData and are reserved names. So you can't use these three words as the names in your names of the fields or variable names. And finally, do not start a variable name with a number. You can have a variable V1. V1 is fine, but you can't have it 1V. So you can't start with a number, but you can have numbers at the end or in the middle. Let's move on. So the third thing that we have to look at and define is field type. Now there are three important kinds of fields. One is a text field, two is a numeric field, and the third one is a date field. So let's go through what these things mean. So text fields are basically also known as string fields, and they can take any string of characters on your keyboard. It can take alphabets, it can take numbers, it can take any other character that is there, or a combination of all of this. So that's a text field. Please note that with text field you can't make calculations. For example, even if you enter number in a text field, you can't use it to make calculations. If you want to do calculations, you must have a numeric field. And there are two kinds of numeric field. One is an integer field, which refers to when you have only whole numbers. The other kind of field is called a float field, where it allows for decimals or real numbers. So these are the two kinds of numeric fields, and this allows calculations. And the third important field is called date field. Now in date field, you can have different formats of dates depending on the country that you're working. For example, in places in Europe, the most common format that they use is date, month, and year. Whereas in US, you use month, date, year format. Whereas in China, you use year, month, and date format. So depending on where you are, you choose the format accordingly. And EpiData allows for all kinds of formats. But for the purpose of this course, we are going to stick to the European format, which is date, month, year format. Now there's another field called Boolean field or logic field, and this is often used in foodborne outbreak investigations, where you have only two options: yes, no, dead, alive, disease, no disease, that kind of thing. But we don't prefer using this because this can easily be managed with numeric fields. And I also see some challenges in analysis when you have coded it as a Boolean field. So we would in fact discourage you to use Boolean field. As I said, we can easily manage this as a numeric field. Next thing that we have to look at is field length. Now, what is field length? It's the number of characters that the value of the field can take. Is this clear? So for example, here you can see that let's say this is the laboratory serial number, and we say that it can take a field length of 4. So it can accommodate a 4-digit number. So it cannot go beyond that. So this is the maximum length that this particular field can accommodate. Similarly, if you look at this date field, we say the number of characters is 10. Why 10? So if you look at the date here, so DD 2, MM another 2, so 4, YYYY, so another 4. So totally 8, and there are 2 forward slashes. So that makes it 10. So any date field, the number of the field length has to be 10. And similarly, if you see here sex, so we have coded it as a numeric variable. So it's either 1, 2, or 9. So accordingly, the length of the field is just 1 because it's single character. So is this point clear about field length? In fact, Epi Data can allow for a maximum of 80 characters as field length, which is a lot. Okay. But in quantitative research, this is a lot. But in most cases, we are probably using less than 10 characters. The next important thing is field values. This indicates the values, the possible values that the variable can take. So for example, in laboratory serial number, we've said that it can take from 1 to 9,000, and then we have said some other numbers. So these are the possible values that it can take. Similarly, in the date, we have said that it can take from 1st January 2010 to 31st December 2011. Any date between these two dates can be accommodated. So this is how you define field values. These are the possible values that the variable can take. Similarly, here we said the only 3 possible values in sex is 1, 2, and 9. So this is the next important thing to define. And this is followed by value labels. This is applicable only in case of categorical variables. For example, here we have a categorical variable called sex. There are different categories: 1 female, 2 male, 9 not recorded. So this is nothing but explanation of what 1, 2, 9 is. So that is called as value labels. It's also referred to as metadata or data about data. This is very important to note. And what we would recommend in this course is, for all categorical variables, we would go with numeric field, take values, and value labels. Whereas in continuous variables, there is no question of defining any value labels because it's a continuous variable. It just tells you what are the possible values that you can take. In continuous variables, you can define a range of legal values, whereas in categorical variables, you have to tell exactly what each of these codes mean. Is that point clear? These are the actual names of the values. So that's it in terms of data documentation sheet. So for each variable, you have to think through these things. Okay, so if you take a variable called sex, so sex is the name of the field. The field label is examinee sex. Field type is it's an integer field of length 1. Then we said field values 1, 2 and 9. These are the possible values it can take. And what are the value labels? 1 is female, 2 is male, 9 is not recorded. And similarly with reference to other variables. Is this point quite clear? So this is what we are going to do in this exercise, to create a data documentation sheet or to create a code book. If you prepare something like this and give it to somebody who knows the EpiData software, he will be able to, in no time, create an EpiData database for your purpose. And you have to ensure that it should be as detailed as it can get. And use the final column called comments or remarks to make as many as you want, so that everything is laid out very, very transparently and clearly. One final thing, we have to note is something called key unique. This is the most important variable in a database. Every database should have a unique identifier. Let us assume for our purpose here in this exercise, serial number is going to be our key unique or unique identifier. Now, without a unique identifier, you cannot create a database. Because if there is some problem and you want to refer to the original record, you must have an identifier variable through which you can reach them. And this is a must. Okay, let's look at a couple of other terms. What's a record and what's a file? Now, I think the term variables or fields is very clear. So for each person or each study subject, you collect several data in terms of several variables. So in this person has data on date, age, sex, tribe, household, etc., etc. Now, all the data of one person constitutes a case or a record. Okay, this is the completed information of one person or one study subject. And a set of records makes a file. Okay, so is this clear? Record is a completed questionnaire for each individual, and file is nothing but a set of records in a study. So when we say rec file, it's a set of records. It's a file which contains several records. And each record contains information about one individual or one study subject on several variables. And in each variable, we have several attributes which have been defined in the data documentation sheet. Is this clear? I think this is very important to learn all these terminologies, know exactly what they mean, because we will be using these terms quite frequently in all our discussions, and if you don't get this right, you will face a lot of challenges in understanding what this software is all about. And this is, you are learning a new software, and learning a software is like learning a new language. You have to become first familiar with the vocabulary, the various terms that the software understands. So if you want to interact with the software, you have to interact using these terms and rules. Only then it will understand you and do what you need. So this is very important to get this. So let me summarize. In EpiData Entry, variables are referred to as fields, so you can use those terms interchangeably. And for each field, you have several attributes beginning from field name, which is nothing but the name of the variable. As I told you, it has to be unique, single word, not more than 10 letters, intuitive, lowercase. Field label is nothing but the full name of the variable. So in a quest file, whatever comes between field name and the field type is all field label. And then field type it could be, the three common types: text field or a string field, numeric field, which can again be two types, integer or a float depending on whether decimals are required or not, and a date field. Field length, field values, which is nothing but possible values that a variable can take. And then in categorical variable situations, you need value labels, which is the actual names of each of the values. And a record is a completed questionnaire for each individual or a study subject, and a file is nothing but a set of all records in a study. Is this fine? Let's move. So one of the things I wanted to introduce is we will be using a common example in the next 2 days, and that is going to be based on a tuberculosis laboratory register. Is everyone familiar with what a tuberculosis laboratory register is? So in the world of TB, if somebody has symptoms suggestive of TB, one of the traditional investigations that is used even till today is sputum smear microscopy. We collect sputum of the patients and get it examined under a microscope, and if we find bacilli, tuberculosis bacilli under the microscope, then we consider the person to be suffering from tuberculosis and start treatment, or investigate further to see, even if the bacilli are not visible, to see if he has TB otherwise. Let's assume we are going to do a study which is based on the tuberculosis laboratory register. Okay, so how do we so let's go through the several things that are there in the tuberculosis laboratory register. So the first column is laboratory serial number. So every person who gets examined in the laboratory gets a laboratory serial number. In fact, it begins on the 1st of January. So the first person entering the laboratory on the 1st of January in a year gets a number 1. And then it moves on consecutively till 31st December. And again the next year it begins from 1. And that's how it works. Date is nothing but the date when the specimen was received, name of the person, sex, male, female, age in years, name of the treatment unit from where he was referred, patient's address in case we want to trace the patient back later when there is a diagnosis. What is the reason for examination? Is it for diagnosis or follow-up? Now, sputum microscopy is used for both diagnosis as well as monitoring treatment response, during follow-up. So what is the reason for examination in this case? And then results of the specimens. So normally we collect 2 to 3 specimens, sputum specimens for examination. And accordingly, the results of those microscopy examination is entered here. Now, the possible results here could be a negative, which means that we could not see any bacilli under the microscope, or it could be positive, which means that we are able to see, and depending on the number of bacilli that is seen, it can be graded further into scanty, 1+, 2+, and 3+. And within scanty, it can further be graded as scanty 1, scanty 2, scanty 3, up till scanty 9, depending on the exact number of bacilli found in the fields examined. So this is in brief the laboratory register, and we are going to use this as an example to create a data documentation sheet. Let us say from this laboratory register, we are interested to extract these 8 variables. So this is a good principle to keep in mind already. Even though there are lots of variables in the original data source, we are not taking everything for our data entry. We are making it very clear right in the beginning that we need only certain variables for our purposes of analysis, and hence we are choosing. So this is the first step to being efficient. Remember, less is more. So clearly from the lab register, understand what are the variables which you will make use of and do data entry only for those variables. And here we have chosen 8 of all the variables that are there in the laboratory register. The lab serial number, the date when the specimen was received, sex of the individual, age, reason for examination, is it diagnosis or follow-up, the result of the specimen 1, 2, and 3. Let me take you through for the first 3 variables how to prepare a data documentation sheet. Let's begin. So the first one is CERNO. Now this is the field name I've assigned for laboratory serial number. So the laboratory serial number, the whole explanation can be placed in the field label, whereas the field name is CERNO, serial number, and that is what I gave. And remember all the principles. It's unique, it has to be intuitive. CERNO, serial number, somewhat intuitive. It's single word, no spaces, no punctuations, no underscore, nothing, and less than 10 characters. So it's a good field name. And I'm saying this, the field type is integer of length 4. Now this is because I know that you will not have in the laboratory that I'm studying, we will not have more than 9,999 people in a year. But if you think yours is a big laboratory and you can have more than that, please increase the field length accordingly to 5. In case, I have seen some big medical college laboratories where the patient load is so high that it can exceed 10,000 in a year. So accordingly choose your field length. But if it's a small laboratory and you don't even find 1,000 people in a year, then probably you can reduce the field length to 3. So choose your field length depending on your requirement and your reality, your setting. The field values here I've defined saying that 1 to 9,000. And then I've said something. So if you see here, serial number starting from 1 to 9,099, of which 1 to 9,000 is assigned for whatever is available in the lab register. And then I'm reserving and assigning numbers starting from 9001 onwards for those situations where the lab number is missing or non-unique. Is this point clear? So for example, I'm already thinking that serial number or CERNO is going to be my unique identifier. So assume a situation in the laboratory that, let's say, a serial number is missing. It's very rare, but it can happen sometimes. Or more frequently what we see is that a non-unique serial number. Somebody got a serial number 100, it's at the end of the page, and in the next page, instead of beginning from 101, you again start from 100. So there are 2 people in the laboratory register who have the same serial number. Now that cannot be possible in a database. You must have the serial number should be unique. So the way to do it is here, if the serial number is non-unique or missing, we are setting up a rule here saying that we will begin from 9001 onwards and assign the numbers sequentially. And as we do that, we make a note of that. So if there is somebody with missing serial number in the laboratory register, assign, let's say this is the first person, give 9001 and make a note of it in the lab register that you have given this code, as well as make a note of that in the EpiData software so that the person doing second data entry knows this exactly. Similarly, if the next person has a missing serial number, you give 9002, 9003 and so on. So this is very important to handle in a variable which is going to be your unique identifier. The second variable is the date when the specimen was received, or a registration date. So here we have made the field name as reg date for registration date. Again, you can't use date as the field name, just date, because it's a function in EpiData. So we have said reg date, which is registration date. And field type, it's a date field, length 10. And then we have defined clearly what are the range of legal dates that this can take. Okay, now this is important in all continuous variables, that you clearly define what are the range of legal values. And always think of a situation when this particular variable is missing in the original data source, and you have to assign a value for that particular missing data. So in this case, I've said 1/1/1800 is going to be entered for reg date if it is missing in the original record. Is this point clear? It is recommended that no fields should be empty in a database, because whenever we see a field empty, we are in doubt. Is it because that the data was missing in the lab register or the original source, or the data entry operator missed entering that data? So we want to force data entry operator to enter something even if the data is missing, so that we are clearly sure here that it has been looked at and it was missing, hence this value has been entered. So to differentiate between data not present versus lapse in data entry, we want to ensure that all the fields are must enter fields and no data fields are empty in a database. And hence, in case the data is missing in the original source, you have to assign a value for that. And that is a principle which cuts across all the variables. So for example, in sex, so this is sex, examinee sex, and not sex of examinee. Remember the rule. Field type, I've said integer of length 1 and 1, 2, and 9, and I've given values and value labels. Now there is no need to define in this situation what are the range of legal values, because we have clearly said it can only take 1, 2, and 9. And also we have clearly said that the value labels, we have coded what 1 means, 2 means, and 9 means. So as a rule, you can remember, in continuous variables you have to define a range and legal values, whereas in a categorical situation you don't have to do range of legal values, because there are limited number of categories and they automatically become the only legal values that the field permits. But you have to give values and value labels in categorical variable. One of the questions that you may have in mind is, why have we defined sex as a numeric variable? Now it can also be thought of as a text variable and make F for female, M for male, and let's say something NR for not recorded or missing value. That would have been more intuitive. F for male, female, and M for male. Why did we choose 1, 2, and 9? Now this is a principle which is very important to understand. There are several reasons why we use numeric coding and use value labels to explain what these numeric codes are in categorical variables. One reason is that computers are very fast in processing numeric data as compared to text data. So if you are using numbers, you are very rapid. The software functions very rapidly. That's one reason. The second reason is that if you have to type, for example, in sex, it's probably easier because ultimately you are typing one character, whether you are typing 1, 2, and 9, or you are typing F and M. Whereas in some other situation, for example, let's say that you have a variable called treatment outcome, and there are 6 possible or 7 possible treatment outcome, like cured, death, loss to follow up, treatment completed, transfer out, not recorded, or not evaluated, something like that. Now, if you want to give codes, then it will be more than one character in several situations. And sometimes, you have to type a text, and more you type, the chance of committing errors are more. So if you have to type the full length cured, CURED, then there is a possibility of making mistakes. So there is an increasing probability rather of making mistakes the more you have to type. So we want to keep it as efficient as we can. And so this numeric coding and using the beautiful feature of value labels in EpiData, provides that workaround. The other important thing is at the time of analysis, also this comes in handy. Let us say at the time of analysis, you want to do a sub-analysis of only females. Now, if you have coded your variable as a string and say male, female, etc., then if you want to select, then you have to say select sex equals female, exactly the way you have defined, and put it in double quotes. And again, there are chances that you will commit errors the more you have to type in the program. Whereas if it's a numeric coding, you can clearly say select sex equals 1 and be done with it. So this approach of using numeric variables, even in case of categorical variable situations, use a numeric coding and use value labels works well. So is this point clear? How to make a data documentation sheet? So let's go ahead and do an exercise. So I have shown you how to make a data documentation sheet for 3 fields. Now, why don't you finish the data documentation sheet for the rest of the fields? Okay, so this is the questionnaire that we have, and I have finished writing the attributes for lab serial number, the date specimen receipt, and sex. So why don't you do for this as well as the other variables: age, reason for examination, and results of specimen 1, 2, and 3. So please try it and then come back for solution. So if you are watching this video, stop watching it here, go and do the exercise, and then come back for solution. Please note that do not forget to provide a value if no answer was provided to a question. I mean, for each variable, if the value was missing in the original source, how it should be handled. That rule should be clearly mentioned. Let's discuss the solution now. The first thing I have to say before I discuss the solution here, there is no single correct solution. Okay, so what I'm going to discuss is not the only solution. There can be many possible correct solutions. So if what you have done is going to be a little different from what I'm going to discuss, it's fine. As long as you are following the principles and it is applicable for your setting, that's fine. But probably you should look at this particular solution and appreciate the thinking that has gone behind making this data documentation sheet. Let's begin. I think we have already discussed Cerno, regdate, and sex. Let's go ahead with the next one, which is age. So we have said the field name is going to be age. The label examinee's age in years, and not age of the examinee. You remember the principle? The name of the variable and the first word of the field label should not be same. And we said this is going to be an integer field, I, indicating for integer field, and the length will be 3. Okay, if you think in your setting there is nobody who is 100 years or more, then you can just make it 2. Okay, but in our case we have made it 3, and we have given a range of legal years as 0 to 125. Okay, so this is examinee's age in completed years. So if we have an infant, he would be entered as 0, and that's the reason we are allowing for a 0, and it goes till 125. And we have already mentioned very clearly that if age is not recorded, enter 999. Is this clear? And this is another small principle that I want to bring to your attention, that every time there is a missing data, we assign a value. That's one. The second thing is, every time I assign a value, it's for missing data. It's like 9, 999, 99. So there is a convention that I'm following, and it's a useful convention to follow, because once you are following that, whenever you have a database and you see a value like 999 or 999, then you know for sure that this indicates missing data. Whereas in reg date, I have not used the date like 99, 99, 9099, because the reason I did not do that is the Epi Data allows only for legal dates. For example, there is nothing like a date 99, and similarly there is no month 99, so it does not even allow for that. So you have to use a legal value for that particular field and still make it intuitive. So for all dates I use 1/1/1800. So it's useful to follow such conventions. Now let's look at the next variable, reason for examination. So we said examination reason, again an integer field length 1, and look at the field values. Begins from a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have said this is a categorical variable. Once again, we are following a principle of numeric coding and providing value labels. Whereas in age, it's a continuous variable, so we have defined a legal range of years. Okay, so I want you to note here, I've given a 0 for diagnosis, and then depending on the month of follow-up, I've used the numbers 1, 2, 7 for denoting follow-up at 1 month, 2 months, 3 months, so on. And for 7, I've said follow up at 7 months or later. Okay, and 8, I've said sometimes follow up is mentioned that this is a case of follow up, but the month is not stated. So I want to give a code of 8 in such cases. Sometimes the reason itself is not stated, whether it is for diagnosis or follow up is not clear, in which case I want to use our usual code 9. And again, this is intuitive, and if just think about it, if I had not used 0 and had begin from 1 for diagnosis, 2 for follow-up at first month, 3 for follow-up at second month, then it would have posed a lot of challenges for the data entry operator, because it's not intuitive. Whereas now it is intuitive. 1 means follow-up at first month, 2 means follow-up at second month. So making this as intuitive as you can is very important to prevent errors. Okay, remember, this is all about quality assurance, and all of these thoughts are very, very useful. And the second principle is, whatever is the most common value should be on the top. So for example, most patients in a laboratory register, maybe about 70%, are for diagnosis. So I have given diagnosis 0 and have kept it on the top. It is the first option. You will see later on during data entry that the moment you enter into the field, the first value is already selected, and you can just press enter and move on. So the most common response for a variable, or the most common value that a variable will take, should be on top. So this is another small tip that you have to keep in mind. Let's go to the next variable, res1. I've said it is res1, the name of the field, result of specimen 1. Now, if you see here, I have made an arrangement here to capture the result of specimen 1 in 2 fields. Now, as I told you, there are several possible values that this field can take, and there are several different ways of actually doing this. So in fact, if I remember, in our previous courses, we had recommended to use this as a single field, and that is going to be all possible 17 values in a single field. And we had coded something like this, 0 for negative, very clearly, again intuitive, 0, no bacilli, negative. The most common response is negative. So 90% of all people who get examined are going to be negative for TB bacilli. So it should be the first topmost response, and 0 again intuitive. Then 1 for 1 plus, 2 for 2 plus, 3 for 3 plus, again intuitive. But earlier we used to do, make it a decimal and include the scanty results in between 0 and 1, which is actually the case because it's not negative, but it's not 1 plus. It's somewhere in between, few bacilli, and that is what we call as scanty. And there are 9 different levels of scanty: scanty 1, scanty 2, scanty 3, up to scanty 9. So we said earlier that it is going to be a float, a decimal field, and 0.0 will be negative, 0.1 is scanty 1, 0.2 is scanty 2, so on, 0.9 is scanty 9, and then 1 is 1 plus, 2 is 2 plus, 3 is 3 plus, and of course 4, 5, 6 and 9 as we have mentioned here. So that is one option, but the disadvantage of that option was that it's a float field, so there are at least 3 characters, 1 character before the decimal itself, and 1 character after the decimal. And so that means 3 keystrokes every time you enter data. So every keystroke matters, and more you have to type, the probability of committing errors are more. So we sort of moved from that idea, and we are currently using this particular approach where we have 2 fields to capture the same thing. So look at this. So res1 will capture simply 0 negative, 1 1 plus, 2 2 plus, 3 3 plus, 4 for positive, not quantified. Some people just mention pos or p in the laboratory register without quantifying whether it is 1 plus, 2 plus or 3 plus. So that is positive, not quantified. Sometimes people mention just scanty instead of saying whether it is scanty 1 2 3 4. So that I have given a code 5, scanty, not quantified, and create a separate category 6 for scanty quantified, and 9 is usually result not recorded. And if scanty quantified, then that result I'm capturing in a new field called res1sc, which is result of specimen 1 scanty. Now look at the comment I made. If the entered value is other than 6, then write 0 into the next field and bypass it. So I'm going to create a rule. I'm making a rule here. If the value of the field res1 is going to be anything other than 6, then the next field is really not applicable. So I'm saying you have to type 0 in the next field and jump it to the next. So that is what I'm writing a rule. But if the entered value is 6, which is scanty quantified, then ensure that 0 cannot be entered into the next field. If this is 6, then you can't have 0, and you have to choose one of the 1 to 9 options. Is this clear? So this is how I'm setting it up like this. As I said, this is one approach, and the reason we said this, it has numerous advantages in being efficient. One, we are keeping the field length 1 in all the cases. Okay, less keystrokes, more efficient. Number 2, it's intuitive. 0 negative, 1 1 plus, 2 plus. We are maintaining that intuitive arrangement. And then scanty results are going to be rare. Okay, in diagnostic samples, it's usually 10% of all positive samples, and in follow-up it could be 20% or so. So it is going to be rare as compared to other results. Hence, we have created a separate field for it and only when it is mentioned we go to that field. Otherwise, we simply use an option to jump that field and go to the next field. So this is one of the ways we have tried to keep it efficient and rapid, and we will see how it all works later on. Similarly, we have done for result of specimen 2, result of specimen 3. Again, 2 fields for each of this particular thing. And if you note the last one, so for example here, if the entered value is other than 6, then write 0 into the next field and bypass it. Whereas if you go to res 3, you can write 0 into the next field, but there is nowhere else to go. So you have to next go to save the record to disk. So we have thought through this and actually mentioned it, and we will see how it will all work in an EpiData database. Okay, so this is, as I told you, is one of the solutions which we think is very efficient, but there can be number of correct solutions. But for the purpose of this course, what I would request is, let us stick to this solution and go to the next exercise, taking this solution as our solution. Is this point clear? Every time we finish an exercise, you try it and you can have your own solution. But before going into the next exercise, we will take the solution that is provided in the course manual and move further, so that we are again on an uniform slate before we begin each exercise. Thank you very much.